Hi everyone. Let's start with our today's topic, that is time series modeling. In last two sessions, we discussed more about return, standard deviation, and a lot of other ways by which we can calculate different time factors. Especially the financial data, the way we can calculate different types of financial parameters, so that we can then move into the forecasting part, which is more about time series. So there are multiple ways by which you can do the forecast, especially if you have the financial data. Time series is one of them. So there are models which depends on multiple factors. So you've got regression models, you've got multivariate models, you've got classification. There are different ways by which forecasting is kind of done. But our current focus, today's focus is on time series modeling. I believe that we've got basic foundation ready and now to move into some of those applications of the Python. So today we'll be starting with time series modeling. I would like to give you an overview of time series, or why do we use time series, or what is time series. So time series basically, if you see any sequential data, and if it is say data which has got time as one of the variables. So if you have sequential data, say you've got data about rainfall, whether it's daily, monthly, or annual data, you still have it is evenly spaced, which means that you've got a sequence of time events, and then you've got value for that particular variable in those time events. So when I'm talking about financial data, you've got stock prices, right? So every day you've got price. So that way you can create a time series chart to see that how is that time series moving, how that stock prices are going in which direction. Similarly, you've got asset prices, which means you've got gold prices, which are commodity prices, or you have crude oil, all kind of commodities, right? So everything is dependent on time somewhere. So we've got a time series for any of those financial assets, right? So that's why it becomes very important to understand how can we then do the prediction, or we can come up with some kind of insights from those time series kind of a graph, which will be kind of creating in some time. The idea here is to understand more about the forecasting aspect of it, but before that we need to also uh, understand that what are the assumptions behind time series. Now, since our focus is again, since this is more of a Python course, so our focus again on Python codes. So I'll be starting from usage of different Python codes or different Python libraries so that you can come up with better analysis. So let's start with our basic stuff first, which is importing libraries. So I'm going to import pandas and Quandl. Now, in last session also, I discussed about Quandl, and this is something which is a very great, API by which you can get any kind of asset data from this particular source. So I suggest that you can go to that particular website, you can log in yourself there, and you will get one Quandl key. Once you get that, you can use the way I have put my Quandl key here, and then you can get the data set, whether it is gold data or any other commodity or any other kind of financial indicators, whether it is inflation data or any of those CPI metrics or WPI, or that kind of data, any of those macroeconomic factors, if you are looking for, you can get that kind of data from Quandl. That's a very great API. I must say that you should go on that website. And my aim in this particular course is also to equip yourself with all kind of tools so that you can, better play with the tools, and then you have better analysis done. Whether you are working as at an individual level, or you are working in some kind of a bank or any of the companies, right? So that you can do all kind of analysis of your student, right? So that you can understand in this Python world what all we have, right? So let's now uh, import our data from this particular Quandl. So what I'm doing here, I'm getting data of gold that is in USD, starting date is 1st of January 2000 and end date is 31st December of 2010, right? So what I'm doing here is creating a data frame. So I'm trying to explain you the code as well, whereas this is very straightforward. And I kind of assume that you have a bit of Python understanding. And at the end, you will also have this code at your disposal so that you can yourself see this code and can understand that what is happening behind the scene. But for your understanding purpose, what we are doing here, we are basically resampling. Initially, we are extracting the data. This is a daily data. So we are extracting it from 1st of January till 31st December 2010. So basically, we are taking data for 10 years. Then we are doing the resampling on a monthly basis. So basically, what we are doing, whatever is the month end price, whatever is the month end price, since we don't want to do analysis on a daily price because we are kind of not doing that. But if you want to do it, you can do it very well. But my idea here is to take the month end data set, since that data set is manageable. Otherwise, it becomes little lengthy data set, and your processing will require higher processing. But since we are kind of doing the the practical, so my aim here is not to spend a lot of time in processing that. That's why I'm taking the monthly data. So let me import this monthly data. I've got this monthly data with me. I will be showing you the structure of this data. So you can see here we have what data starting, and this is the month end data, as I said, for every month. So you can see that we have data from 31st of January till 31st of December 2010, and we have the gold prices in USD. Now, as a next step, what I'm doing here is I am basically plotting this in a chart so that you can see the real time series now. And that's why it becomes very important, because you need to see if you can find any kind of a pattern or a trend in this particular time series. And if you, for that matter, if you take any stock prices, any of those asset prices, anything, you will find some kind of a trend or a pattern, whether you might find some kind of an increasing trend or a decreasing trend or some kind of a pattern, right? So that helps you in doing the forecasting. And that's the objective of time series. Here you can see that our trend is increasing, and that's quite likely just because we are looking for a long-term trend. And normally in a long term, any asset prices go up, and there are reasons for it. One of the reasons is that we've got inflation, right? So inflation is always going up. You must be seeing that even anything which you used to purchase, maybe at your childhood, the price of that particular stuff is much higher today. So one of the reasons is inflation, because inflation is always rising. So you will always have the prices of the asset going up. But also at the same time, there are also other factors which are demand and supply. There are also the usage of the product, and also at the same time, there are macroeconomic factors. So on the basis of that, the prices you will find going up or going down. But most of the times in a long-term series, you will find prices going up. There's always an increasing trend, which is also seen in this particular case. But you also can see there's also a decreasing trend if you take this particular time duration. So there are ups and downs in this time series. It is always going up. So we need to find, because we normally are not a long-term investor. That's why I advise people to be long-term investor, because if you are a long-term investor, you will find whenever you invest or wherever you invest, even if you invest here, or even if you have invested here, you will still find that price is going up, right? So in the long term, you will always find that you are making money. But in short term, if you have invested here and then you have no patience, right, you might lose your money. So that's why it is I normally advise people to be long-term investors, but also at the same time, we can also identify patterns in short term and can make some money. But then again, we need to be very smart, we need to be very cautious, and we need to be very much financially educated for that. But again, the aim of this course is not to make money in stock market or in any other market. The aim of this course is to equip you with all the tools which are there so that you become more of an informed investor, right? So that's the aim of this course. Now we can see gold prices here. Now what I'm doing here again, as I said that in our last sessions, I have created bit of a foundation. Last time we discussed about rolling mean and rolling standard deviation. So the similar thing which I'm plotting here. So why rolling mean and why rolling standard deviation? Because this is more of a smoothing of your trend. You can see the green line is of rolling mean, and here it is more smooth than the kind of patterns which we see in our regular prices. And the reason for that is that, and in this particular case, we have taken 12 months moving average, right? Window size is 12. So basically, we are taking 12 months and taking the average of that. And accordingly, we are taking the moving average for last 12 months, right? You're basically, you get the smoothing in your time series, and that's why you would have seen also in stock market people talk a lot about moving averages. So this is actually a moving average. Now why a moving average becomes very important, because it somehow reflects some kind of a trend. So normally what happens that when people are somewhere here, they feel that's an increasing trend, right? But it has to be also reflected somewhere in your moving averages, because moving averages are lagged indicators. They are lagged indicators. So basically what they do, they are always looking for the data, and then if you find, and especially if you take 52 weeks moving average, or say, especially if the moving averages are of long duration, then they will not be changing very fast. So you will not find trend changing very fast. It takes time for them to change their course, right? That's why whenever they are changing their course, we normally can say that we are moving into some kind of a declining or decreasing trend or an increasing trend. So it is always, good to not go with the sentiments of the market and invest your money wherever you see it is an increasing trend, and suddenly you find it drops. You need to wait for an indicator from the moving averages, and moving averages again one of the tools. There are many tools in technical analysis. Again, I'm not doing technical analysis here, but I'm just giving you all kind of knowledge, whatever possible, so that you get equipped with this as well. So that's the idea. But then again, the moving average, why I'm showing here is because, and we also have standard deviation again, which is our volatility. Again, how volatile the stock is. So you can see that standard deviation increasing here, because this is again 2008 subprime crisis, right? That's mortgage crisis, right? So this is where that lot of changes were happening. Stock prices going up, all of a sudden going down. So that becomes a volatile scenario, volatile environment, right? So you can see that this is again a moving standard deviation. It talks about the risk of that particular. So it's not always returns, it's always risk. You cannot see returns in isolation. Gold price is very safe, right? That is because they are not very risky as well. You might have some small cap stocks doing very good, giving very high returns, but also at the same time very volatile, very risky, right? So we need to always look returns along with risk. We can't see returns only in isolation, right? Okay, so now once this particular chart is created, the idea here is again to look into some kind of a trend. Once you have a trend here, now we want to, and the best part, why we are doing time series? Because time series consists of some kind of a trend and also seasonality, right? And also it has got some kind of residuals, right? So you want to decompose your time series. Why seasonality? Because many times you would have observed that any asset price going, maybe say in January, going up just because there is huge demand, because there is festival season, or this is winter, any of the commodities going up. Say for example, you would have seen in crude oil prices, it is going up in winter times just because there is huge demand of crude oil during winter, especially in European or rather Western regions, because there's cold, right? So they need that for heating. So those kind of seasonality you find, and festival season, gold prices going up, right? So all those kind of seasonalities are there. So we need to again become an informed investor. We need to also find from our time series whether there's seasonality in our data or not. And also, if we have a trend and if we decompose that trend into seasonality and also into residuals, right, we can find some kind of a way to forecast our prices, right? So moving now to another model, you can always import this model. And see, the good part here is that we've got everything on our disposal. There are some good people, those who have worked and come up with some kind of nice libraries, right? So we just have to import that, and we need to, just put our data, and then everything is kind of done by those people, right? So now if you see, what I'm doing here is I am decomposing my df dot price, which is my gold price in this case. I'm taking multiplicative model. There's also an additive model. So basically, there's not much difference. But idea here is that if you want to do the forecasting, you would have to multiply these three items, which are trend, seasonal, and residual. So I'll just explain you that. So you have this your regular price. Then you can see this is a trend which our model has identified. And since we can see from here, this is an increasing trend. It is also showing an increasing trend, which is quite visible here. The next thing, which is quite significant in this context, is the seasonality. And you can see that seasonality is very much similar in any of the years, right? Whether there was a decreasing trend or not, whether it was subprime crisis or not, still it is kind of holding very well, which kind of gives us an indication that every year, somewhere in Jan Feb or the start of the year, the gold prices go up. Somewhere in September month, gold prices go down, right? Uh, that is quite visible, right? So that shows that there is some kind of seasonality in gold prices. You can do the similar exercise for your other assets. You can, for that matter, even take the stocks. You would find some kind of seasonality in stocks as well. Seasonality, this is a monthly seasonality. You can even find seasonality in weekdays. You would find Black Friday prices going down, Monday, prices going up, or within a weekday, maybe on weekends, some things go up, right? Or maybe on Monday because of demand, huge demand, right? So there is always some kind of seasonality, either in in weekdays or in a month. So idea is to identify that, so that we then can do a better forecasting. And this is what we have, the residuals. So which means that after that, whatever is left, so if we need to find this particular price, we need to multiply this trend from this particular month seasonal factor and this particular residual, then we get this price. So now, since we know our seasonal component, we already know it is constant. So for forecasting also, we can have the same seasonal factors. We also know the trend somewhere going up, and accordingly, if we can take the trend for future periods, and if we can forecast our residuals, which is a tricky case, because residuals are not easy to forecast, but we have our models which can forecast the residuals. If we can forecast that, and if we multiply all those three components, then we can predict the future gold prices. So that's how these models work. So this is one of the examples. We've got ARIMA models. We've got, in neural network, we have LSTM models now. We'll reach there, but, we'll have to have our basic foundation ready first. We've got all kind of neural networks doing all kind of forecasting. We've got all regression models, doing forecasting as well. We have our classification, supervised learning, we've got machine learning models, AI doing all that, right? So we'll be reaching there, but I'm starting with the foundation. So let's focus on this first. We'll reach there. Now, the important assumption in any of the time series, that we need to have the stationarity. Now, the time series needs to be stationary. What do we mean by time series to be a stationary? Which means there should not be any trend. Which means the mean of the series should not be always increasing or decreasing. It should be constant. It should not be like in this case. If you see, our mean is always increasing. It depends on the time, right? You can see the trend here, which means there should not be any trend if series needs to be stationary. Then the variance. So sometimes you are finding, I will just take this example. Here you're seeing the variance is increasing, and here variance is less. But after 2006, this variance has increased, right? So if variance is increasing, that means our series is not stationary. The third thing is covariance. So basically, there should not be a covariance. So this is a new term which I have introduced today. You know about mean and standard deviation. Covariance is more about correlation. So it is something where there is a relation between two series, right? So if suppose if I take an example, you have stock prices going up and GDP going up, both together, right? So your inflation going up, stock prices going up. So both are highly correlated. So if something is going up, the other thing is also going up, or something is going down, it has an impact on the other series, right? So that means there's a strong correlation between those two series, right? Now in time series, how do we see correlation? Sometimes, which we also call autocorrelation, that is something we take a time series, say from first to 365 days, then we take another series, which is say 2 to 366 days. So basically a lag of 1 day. And then we compare both the series, and if we see if there's a correlation between those two series. We'll come to ACF, we'll come to autocorrelation. But now, for time being, you should understand that there should not be a covariance. Covariance should not be a function of time. So that means covariance would be there, but should not be increasing or decreasing as per the time. Now, I will not be going a lot in details again, just because this is more of a Python course. Why is it required? Because as I said, that always a trend and seasonality we can forecast from different ways if it is there. But we want to make our series stationary so that we can then the tools which we have are like ARIMA models or different models. They only work when you find series being stationary. If it is not stationary, you cannot apply those models. You need to make that series to be stationary, right? So, so how do we do that? How do we make our series stationary? Since we see in our gold prices, they are going up, right? And we need to also learn our ARIMA models going forward, and we need to also develop other models where this assumption is there, right? So we need to ensure that we've got stationarity intact, right? So I am now going to take the data again. Again, I am taking the gold prices. Again, I am doing the similar thing. I am taking the monthly data. I've got the data with me now, and you can see the chart where again we have this similar kind of a chart where gold price is going up. I am kind of importing now some of those libraries. The important one here is AD Fuller. ACF and all we are not using, so you can ignore that. Now, what is ADF test? This is augmented Dickey Fuller test for stationarity. Again, I'm not going deep into it. Not for, I don't think that we should be spending a lot of time there. What is important here is to understand we have developed a function here which does the testing of stationarity. Now, what you should understand here is, now I'm taking a data frame price. Basically, I'm taking gold prices where I have not made any changes. It is like a regular gold price, which is a monthly gold price. I am now calculating the p-value. Now, there's again a lot of stuff here. The t statistic or test statistic, the value of that is 3.5. P-value is 1. The most important thing here is to see the critical value, which is, now when we say 1, for the hypothesis which we have here. Now, if you see in this particular augmented Dickey Fuller test, the hypothesis, null hypothesis, we say is time series is not stationary. Alternate hypothesis is time series is stationary. So if we have to reject the null hypothesis, we need to have p-value which should be less than 0.05, which is at 95% confidence interval. Again, all of these are statistics, and we need to be knowing all this. But then again, since we don't want to go in literature, my only point here is that we need to see that p-value should at least be less than 0.05. If it is not less than 0.05, if it is more than 0.05, like in this case, we cannot reject the null hypothesis. And our null hypothesis is time series is not stationary. So which means we cannot reject this. And if we're not rejecting it, then we need to accept this, which means time series is not stationary. And which is also the case, which we can see. We can see the increasing trend, variance, and everything in that particular series. So that means it is working well, and it is saying that your time series is not stationary. Now, in the next step, what we need to do is we need to correct. We need to make our time series stationary. How do we do that? Right? Again, what I'm going to do here is I'm importing some libraries. This takes time, but I also like to tell you while it is taking, while it is kind of importing those libraries, we are using three approaches to show you that how can we make time series stationary. So the one is that we need to import CPI. CPI is again, basically what we are doing here is we are taking the inflation data. As I said, that whenever you have an increasing trend, most of the time, the reason for that is since you also have the inflation. So the prices will surely go up, right? But if you exclude inflation from your prices, then you might find those prices being constant, right? So that if prices are constant, that means that there's no trend. It is constant. Their mean is constant. So you can think of deflating your prices so that you have a very a very flat kind of a trend, which means your mean is constant over the period of time, right? And that shows that you have mean constant over the period of time, right? So we've got our libraries kind of now imported. So this is what I'm doing here. I have taken deflation date of 31st December 2011. I am doing the deflation of prices here. I will also show you the chart. How is it happening? So you've got price and then you've got deflated price. So basically in green, what you have is a deflated price, and in blue, what you have is your regular price, right? But now again, in this, I can see that the factor is not only inflation. There is definitely a trend in gold prices, which means it is an increasing trend. It is a good asset. It is giving good returns to people over the period of time. Even if you adjust for inflation, it is still giving good returns. But from our analysis point of view, we can also see that this is again not stationary, and this should reflect in our ADF test. So again, I'm going to do the ADF test on the deflated prices, which we have calculated. Again, you can see key value here is 1, which is 100%, which means that you still have not rejected the null hypothesis. It has to be less than 0.05. But in our case, we could not again reject the null hypothesis, and we still have to accept it, which means that our time series is still not stationary, and which is also kind of visible. So now the next thing what we do is we take the log of the prices. So when I'm saying we take the log of the prices, what it means is, see, if you take the log of 10 is 1, log of 100 is 2, and I'm talking about 10 as the base of that log, right? So you've got log of 1000 is 3. So you might have a series which has prices like 10, 100, 1000, 10,000, or it's going exponentially higher. But when you take a log of it, it becomes 1, 2, 3, 4. It is still increasing, but not as great as the regular prices. So basically, if there is an exponential trend, what log does is reduce that exponential to slightly increasing trend, right? So that way, like in our case, since we have that increasing trend, so I'm just thinking that if we apply some log in that, maybe it will flatten that curve so that we have our mean constant over the period of time. So I will be doing that, and I'm also kind of taking rolling mean of log and rolling mean of standard deviation. May not be very useful in our context, but still I'm taking that, because rolling mean, even if you get to, even if you find that your rolling mean is constant over a period of time, then you still can use that, because that becomes a stationary time series then, right? So in this case, this is the regular prices, just for your understanding purpose. You can see this is going from say 250 to some 1400 or something, which means this is an exponentially increasing kind of a trend. But here, gold price is still, this is the normal blue log price, and then we have a rolling mean. It still looks quite flat, from 6 to 7. But again, we can see there's an increasing trend in this as well. You might have a smaller change or smaller increase, not like your actual gold prices, but will have still there's an increasing trend. So that means mean is still increasing. And let's now use our ADF Fuller test to see whether we still have we still have p-value which is higher than 0.05, and we cannot reject our null hypothesis, which means we still have to accept the null hypothesis, which is we cannot, time series is not stationary. So we still are not able to achieve that. Now the third thing which we are doing in this particular case is we are taking the difference. So when I'm saying differences, which means that if suppose today price is 10 and tomorrow is 12, then 15, then 18, then you are taking second minus 1, which is 2, third minus 2, which is 3, basically a lag of 1 day. So you are taking the difference of that. So when you take the difference of that, then you find that even if there's an increasing trend, but the differences may not be increasing. Differences might still be a constant. And this is a very good approach, which is used to make the time series stationary, right? So we are doing this here. We have taken and again, we are taking the log differences. So whatever log we have taken there, we have taken the log differences, and then we have taken the mean of those log differences and the standard deviation. So we'll see if any of those series becomes stationary or not. Okay, so now also you can see the graph of it, and by that you can at least understand we have blue, which is the difference, log differences, and now here you can see that time series is kind of constant. I mean, it's not increasing. There's no increasing trend you can see in this. Variance is also kind of constant, is slightly going up. You can see a lot of ups and downs in this particular, but it is still kind of constant. Here also you have something highly volatile, right? So still it looks like rather quite constant, right? So let's see now if we apply our ADF Fuller test here. Yeah, and you can see p value is 10 to the power minus 15, which is like decimal 0.0003, something like this, which means less than 0.05, right? So that way we can reject our null hypothesis now, which is test series is not stationary. We are rejecting it, which means we are saying time series is now stationary, right? Okay, so we are able to achieve our stationary time series now. Now, once we know this is a stationary time series, we can do prediction on this. And whatever differences we applied on that prediction, and accordingly we can get the final price. But all of that is again something we have ARIMA models for that. That will be covering maybe in next few sessions. But for this session, I think my idea was to help you understanding what time series is, how can we get the stationarity. So what we have learned today is about time series. So you have seen different functions. You have seen a kind of time series, especially the gold prices. You can on your own experiment about different other commodities. Then we also see some seasonal decomposition. We saw that there is a trend in time series. There is also seasonality in time series. There are residuals in time series, right? Then we also discussed about what is stationarity, and if suppose there is a stationarity in time series, then how do we remove that? We discussed about 3 approaches. We talked about CPI, deflationary, basically how to deflate your time series. We discussed about how to then do the log, so that you reduce the exponential trend of time series. And then we finally discuss about the differences. And these differences can be single difference or 2 differences or 3 differences. You can have a time lag of 1, 2, 3, 4 days, or you can have a difference of differences, second order differences, third order differences. So all of that is there, right? But the idea is to make this time series stationary so that we can do the forecasting of that. So I think that's for today's session. We'll just end the session now, and yeah, thanks for joining.